Dear students, in the last class we studied about the introduction part of the chapter. Today we will see a few more terms. So let us have a recap of the last class. We learned the definition of the reliability, and we also know that the reliability is classified into two aspects. One is system adequacy and another is system security. So still few more terms are there. One more important term which often that will come in the chapter as well as in the textbook is outage. What is an outage? Outage is condition or a period of time that a system fails to provide service. Suppose we call it as a line outage. Means the line is out of order and that period there will be no service. So few more things, that is the next term is contingency. What is this contingency? So very often this term comes, everyone should know what does it mean. Contingency is the loss of failure of a small part of power system. So it is either a loss, suppose one part is not working, so the whole system may not provide the service. That is one of the thing that is related to contingency. So contingency in your textbook it is written as it is given, contingency is a loss of transmission equipment or generation units. Either there will be some fault, there will be something that the service may not be provided because there is a loss of transmission, means there is some fault in the transmission line, or there may be some fault in the generation units, means there is some problem with the generator. So one more important term that often that will come across in our textbook, that is N-1 reliability criteria. What is this N? N-1 criteria states that a system that is able to withstand at all times an unexpected failure or outage of a single system component has an acceptable reliability level. So what does it mean? It is one of the reliability criteria. It means that the system is made up of so many components. Suppose in such a condition, if one component is not working, suppose if one generator is not working, still though the system works, then we call it as a system has got some reliability. Means there is some backup plan, there is some standby generator. If one is not working, the other we are running it. So that is nothing but that is the system will not be put into no service. So there will be service. So that is if one component is not working, still though the whole system works, that is nothing but N-1 reliability criteria. So if contingencies occur, so in a practical scenario, there may happen, outages will happen and other things will happen. So what should be done? If there is no service, there is no power, so what should be done? The first is contingency analysis is the first step. First we have to analyze that why this problem has occurred. First find the cause, detect the fault and rank them according to the severity. First we have to find the cause. What is the cause? Why there is no service? Why there is some problem? Next we have to detect the fault, whether the fault is with the line, whether the fault is with the generator, and finally we have to rank them according to their severity. So there may be different levels of severity. So next is critical contingency lead to the system from an alert state to emergency state. We all know that there are 5 states, from normal state to emergency state. So emergency state is nothing but it is a worst state. So we should always avoid the system should enter into emergency state. So this critical contingency may lead to a system from an alert state to an emergency state. So in this condition there are 2 possible responses. First is modify pre-contingency state to eliminate the potential emergency. What does it mean? We have to modify the pre-contingency state, means the good state, means before the contingency, how the state was. So we have to eliminate what is the cause for that emergency. The first is modify pre-contingency state to eliminate the potential emergency. The second is we have to define a control strategy to handle the emergency. These are the two possible responses. So control action has to be taken is determined by security level of the system. So in order to avoid all these contingencies, in order to avoid any such untoward things, so we have to take a control action has to be taken. So it is determined by the security level of the system. So this is a function of energy management system. That is called EMS. So what is an EMS? Energy management system is combination of advanced metering hardware and software to monitor electricity usage, identify inefficiencies, and pinpoint potential threats to reliability. This is the definition of EMS. So EMS is nothing but it is a combination of hardware and software that is going to monitor the electricity, that is going to monitor the whole system, and it will identify any faults are there, any potential threats are there, the threat to the reliability. So SCADA is one of the example of this EMS. So EMS has defined 6 levels of security in the system.